Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello students, I welcome you to Eko Learners Support for WAEC and NECO candidates. Today's class is going to be very interesting. I am your chemistry instructor, Jima Rashid. Today, we will be looking at a very important topic, which is chemical reactions.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
I want you to write the topic in your notes as well as the date. Okay? Let's go. We have set the following objectives for us to be able to evaluate the progress at the end of this lesson. 1, you should be able to explain the different types of chemical reactions. 2, you should be able to appreciate the role of chemical reactions in everyday life. And finally, you should be able to conduct simple experiments to observe and analyze chemical reactions. Are you ready? Of course, let's go. So this is the presentation for our class today. We will be learning about what a chemical reaction is. What are some examples of everyday reactions that we have? How do you know that the chemical reactions are occurred? What are some indicators? What are the evidences that you can see that will make you to say that a reaction has taken place? We will also look at different types of chemical reaction. And finally, we will not end the lesson without looking at the top 5 exam-styled questions. I want you to stay right to the end of this video so that you can participate in the top 5 exam-styled chemical reaction questions. So, what are chemical reactions? You look at the picture there. She made a delicious soup, but now the soup is producing an offensive odor. That's as a result of chemical reaction because bacteria in the air have degraded the food, and that's why this is an example of what we call fermentation or decay. So I want you to write down, a chemical change is the transformation of one or more substances into new substances with new properties. The emphasis here is on new properties because a new product, a new substance is produced anytime a chemical change occurs. Burning of paper is an example of chemical change because a new substance, which is ash, is formed. Let's go. Some chemical reactions absorb energy. These are what we call endothermic reactions, such as the chemical reactions that cook food. You see here, an egg is being made and the egg is absorbing energy, the heat energy from the heat there, using it to cook the egg. But there are other reactions that releases energy to the surroundings. And that's why we have here that other chemical reactions release energy in the form of light and sound, such as the burning of wood in a campfire. So I ask you, what do you call such reaction that releases heat to the surrounding? I just told you about those that absorb heat, endothermic. So what do you think these type of reactions are called? Did I hear you say exothermic? You're very correct. So chemical reactions in your body are also occurring, and they are the ones that are keeping you alive. We talk about digestion, we talk about respiration, and these are among the fastest chemical reactions that are ever known. I want to ask you, what if the reaction that helps you to get energy from food is a slow reaction? I'm talking about respiration. If it is a slow reaction, what do you think that does to you? It means that it's going to take some days before you get energy from the food that you eat, and that you don't want. And of course, nature has made it easy by making such reactions to be very fast. Okay, scientists are constantly working to find new kinds of chemical reaction, and you are one of those scientists that we are hoping will also keep working to be able to create more reactions, new reactions that will have useful products. Okay? Now, let's talk about reactants and products. Okay, I have in the picture here ingredients that are used for making cake. Okay, you have the flour, you have the egg, you have the oil. Now, you can call all of these your reactants. And the cake, which is made in the end, that is your product. So if you are to make a cake, you will start, of course, with the ingredients. You will mix them, you will bake them, and they will give you your finished cake. All right? So these ingredients that you put together, they are what you call reactants. What do I call them? Reactants. And of course, the finished cake is the what? Is the product. If you look at what we have here, so if you have two reactants, A and B combining, once they combine, they give you AB, which is what? Which is the product. All chemical reactions involve the conversion of starting materials that are called reactants. So a new name or a way to describe reactants is that they are the starting materials. And the species that are produced or formed at the end of the reaction, they are called products. All products have different properties that are different from the reactants. These new reactions may produce substances with different colors or different states. Now, let's now talk about the different types of chemical reactions that we have. We have a whole lot of different chemical reactions. We will not be able to exhaust them in this video, but we will look at some of them. Okay? You have synthesis, decomposition, displacement, combustion, neutralization, precipitation, double displacement, and redox. Like I said, the list is endless, but let's just see how we can discuss some of these. Now, let's start with the synthesis. Now, what you call synthesis, okay? What you call synthesis is a type of reaction where you have two different elements put together to form a compound. For example, you can have hydrogen gas plus oxygen gas, okay, put together to give you steam. That is an example of synthesis. We call it direct combination. Just you putting two elements together to form a compound. Now, what if I ask you to react sodium and chlorine together? What is going to be the product? Did you say sodium chloride? That's wonderful. So that's an example of synthesis. It is usually putting elements together to form a compound. Then we have what we call decomposition. What do I call it? Decomposition reaction. Now, when you decompose, what does that mean? Very good of you. It means to split. Okay? So that is the type of reaction whereby a complex compound is split into simpler ones. For example, we can have calcium triisocarbonate 4. Sorry about that. We can have calcium triisocarbonate 4, okay, which you can split, okay, to give you calcium oxide, okay, all right. Suppose we have calcium triisocarbonate 4. This is a complex compound here, okay. You can split it. For example, you can use heat to decompose it, and that will give you calcium oxide plus what? Plus carbon 4 oxide. You can see that what has happened here is just us splitting this complex compound to have this. This is what we call what? A decomposition reaction. So we have taken synthesis. Let me give you now an example of synthesis. Hydrogen plus oxygen gas to give you steam. You can see, and you can balance the equation. So this is synthesis. This is synthesis because you are adding two elements together to form a compound. This is what? Decomposition. So we have taken care of this, we have taken care of that. Displacement. Displacement reaction is when you have one element which is stronger than another one, taking the position of that element. Now, let me give you an example. You have zinc reacting with hydrochloric acid. Now, if you look at this, zinc here is the cation here, okay? While hydrogen is the cation here. But if you look at your electrochemical series, you will see that zinc is higher up than hydrogen. And so, it can what? Did you say chance it? That's a good way to put it. So the zinc can actually displace the hydrogen and take its position, and that gives zinc chloride. And you can see the hydrogen there all alone because it has simply been displaced. So that's an example of displacement reaction. Combustion, this is a very common reaction. For example, you can burn carbon in oxygen to give you carbon 4 oxide. This is an example of combustion reaction, okay? When you burn a substance in the presence of oxygen, what that gives you is what we call combustion. Neutralization reaction is a reaction between acid and base. So for example, you can have hydrochloric acid plus sodium hydroxide. Hydrochloric acid, as the name suggests, is the acid. Sodium hydroxide is the base. When they react together, they give you a salt, sodium chloride and water. That is your salt, and this is your water. Okay? All right? Is this equation balanced? You need to check. Hydrogen 2 here, hydrogen 2 there, sodium 1, chlorine 1. It's a balanced equation. So this is an example of what? Neutralization reaction. Don't forget, neutralization reaction has to do with reaction between an acid and a base to form salt and what? And water. Precipitation reaction. Precipitation reaction is a very unique type of reaction whereby you react two solutions together and it gives you an insoluble product. An example is if you have silver nitrate, okay, reacting with hydrochloric acid, okay, that is going to give you, okay, silver chloride plus HNO3. The formation of the silver chloride there is a white precipitate, okay? So redox reaction is a reaction between a reducing agent and an oxidizing agent, okay? So let's move now, okay? So how do you observe chemical reactions? What are the things that you are going to need to see, okay, that will make sure, that will make you to know whether a reaction has happened or not? Change of states. Once you have a compound changing its state, maybe from liquid to solid, from solid to gas, once you have a change of state, change in color, evolution of gas, change in temperature, change in pH, formation of the precipitate. We are going to look at this very quickly. Change in states, for example, when you have hydrogen gas reacting with oxygen gas to form liquid water. So you can see you have two gases mixed together and they are forming what? A liquid. That's an example of what? Of change in states as an evidence. Change in color, like we have said, a bicycle rusting and becoming brown. You can also see the apple there, okay, changing its color, which we call browning. So when you have a change in color there, that is an example of what? Of an evidence to see that the reaction, evolution of a gas. What you have going on here, okay, is when you react sodium with water. You can see fizzling happening there with the evolution of hydrogen gas. Once you see a gas coming out after adding two things together, that tells you that what? A reaction has taken place. And I want you to quickly write a balanced equation for this reaction. Don't forget I said sodium reacting with what? With water. What is going to be the product? And give a balanced equation for that. Change in temperature. Okay, like we said, some reactions can absorb heat, some can release heat. So for example, when water is added to quicklime, the vessel becomes warm due to evolution of heat. So that's a reaction that releases heat. But when potassium hydroxide is added to ammonium chloride, what happens is that the vessel becomes cold as a result of absorption of heat has taken place. What are some common mistakes that students make when dealing with chemical reactions? Number one is confusing types of reaction. Now, I don't expect you to make the same mistake because you have learned about the different types of chemical reactions. Another mistake that students make is misinterpreting indicators of a reaction. So you know the different indicators of a reaction are color change, evolution of a gas, formation of precipitate. So now, this is our top 5 exam-style question. Okay? The question is on the board, and I want you to choose the correct option here. Okay? Option A, colorless, B, yellowish, C, greenish, and D, none of the above. So what do you pick as your answer here? You are adding zinc to copper 2 tetrahydrosulfate 6. What is going to be the color of the solution? What did you say? Of course, you are correct. The solution becomes colorless. It becomes colorless as a result of displacement of the Of the zinc by the copper. Okay? So the second one, what type of chemical reaction takes place when electricity is passed through water? This is a very good reaction. Okay? What type of reaction? This is what we call electrolysis. But what type of reaction takes place there? Is it A, displacement, B, decomposition, C, combination, or D, double displacement? What is your answer? No. Did you say displacement? That is incorrect. The correct answer is decomposition. You use electricity to break water into its ions. When you learn about electrolysis, that will become clearer. But the correct answer is decomposition. Let's go to the third one. When sodium chloride reacts with silver triazonitrate 5, the reaction produces dash and dash. So, what are the answers to complete those gaps? You are adding sodium chloride with silver triazonitrate 5. So, the smart thing for you to do is to write the equation. So, you have NaCl plus Ag NO3. Writing of formula is very important if you are going to be an excellent chemistry student. You must pay attention to writing correct chemical reactions. So this is going to give you sodium nitrate because there's going to be an exchange of ions there. So this and these are combining and this and these are combining, and that will give you AgCl. So produces what? Sodium nitrate as well as silver chloride. So those are the products there. This type of reaction is an example of what? What type of reaction is this? Among all the type of reactions that we have looked at, what do you think this type of reaction is? Did you say displacement? Okay. Did you also say precipitation? You're both correct. Yes, precipitation because a precipitate is formed. Displacement, double displacement, okay, because there's an exchange of ions here. So the two correct answers are double displacement, okay, as well as precipitation. Precipitation because a precipitate is formed in the reaction. Let's quickly look at the fourth one. Okay? This is a true or false type of question. Okay? You have the following statement. Just tick whether it is true or false. Use T for true and F for false. All metal rusts. Is that true or false? What do you think? That all metals rust. Wow. Let me pick my pen. Okay? So, what do you think? The answer is false. Not all metal rust. We have what we call non-ferrous metals, which are metals that do not rust. Iron typically is one metal that rusts. Water and air are needed for iron to rust. Is that correct that iron and air are conditions for rusting? Yes, that is true. You need those two. When iron rusts, it reacts with nitrogen from the air. What do you think? Do you think it is nitrogen in air that makes rusting to happen? The answer is false. It is not nitrogen. Even though nitrogen is present in air, but it is the oxygen that makes it to rust. A layer of paint can be used to prevent iron from rusting. Is that true or false? Yes, you are right. The answer is true. When more reactive metals can help to stop iron from rusting. That is also very true. Very true. You can use more reactive metal, okay, like what you call electroplating. Keeping a bike indoors will stop it from rusting. Do you think that if you keep your bike inside, it will prevent it from rusting? Yes, the answer is true, because it will not be exposed to moist air. So how many of these were you able to get correctly? I believe that you got most of them right. So let's look at the last top 5 exam style question. Okay? When the following reaction occurs when a piece of iron is exposed to moist air. Can you state 2 methods that you can use to prevent this reaction from rusting? The equation you are looking at here is the reaction for rusting, and I want you to write this equation down in your notes. So what are 2 methods that you can use for preventing this reaction from taking place? Number 1 is painting. Yes, painting. You can paint. Painting. That's 1. What do you think the second answer is? Electroplating. Okay? Or by oiling. Addition of oil. When you add your oil to. So, these are our top 5 questions.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
I believe that you enjoy today's class. For you to tell us your feedback so that we can know how you are progressing in your chemistry career. Leave us comments, suggestions in the link displayed on the screen. I hope to see you next time. Bye.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.